Welcome back. Our next fossil fuel, oil, petroleum. So it occurs in underground deposits, as do coal and natural gas. So we have to mine it out some way. It's composed of a liquid mixture of hydrocarbons, water, and sulfur. Coal is pretty much the same thing, but in solid form. There are different types of oil. There's light oil, which is the least dense, so least energy rich. Heavy oil, extra heavy oil, and oil sands, bitumen, most dense. So going from liquid to almost like you ever play with that, like the kinetic sand, like that's kind of weird sand you can kind of mold. Imagine, if you've never done that, imagine sand mixed with Play-Doh, wet Play-Doh essentially. Wet sand mixed with Play-Doh kind of gives that weird consistency. That's what bitumen is. So it's a mixture of petroleum, sand, water, clay. So almost like that. What is that stuff? Kinetic sand? Yeah, almost like that kinetic sand. So it is a fossil fuel. So it is formed much similar to coal. So in this case, typically dead microscopic plants and sometimes animals from the ocean 300 to 400 million years ago, dead, falling to the bottom of the ocean, building up layers above it, and that organic material transformed, compressed with heat and pressure, transformed to oil and natural gas. Oftentimes, when you find oil deposits, you also find natural gas, methane, which more on that in the next unit. It's basically the same process as coal. That's why it's a little bit different conditions, a little bit different stuff that you eat. You get different conditions coming out the backside. Same thing here. With coal, it's more just strictly plants. With petroleum, oil, and natural gas, microscopic plants, and some sea life as well, settling to the bottom of the ocean, building up layers over hundreds of millions of years, heat and pressure altering that organic material to create oil and or natural gas. Or sometimes, again, if that material is mixed in with more sand particles, not so deep, you get bituminous sand, bitumen, right? Bituminous sand. So who has the petroleum? Who has the largest oil reserves by country? Venezuela, it turns out. All right. Oftentimes we think oil, we think Middle East, Saudi Arabia, Iran, Iraq, Kuwait. Those are all there. But Venezuela is definitely second on or number one as far as reserves. And potentially with how much they currently mine out of the ground, they have 362 years left of petroleum, oil, to suck out of the ground, essentially. Saudi Arabia, number two. Canada, number three. A lot of that. So some liquid oil, petroleum, but also a lot of those oil sands, bitumen. And you can see the United States is in 10th. But yeah, Venezuela, number one. It's more of a recent discovery, too, bringing a lot of wealth, but also a lot of corruption to that country, unfortunately. Sorry, there was a little glitch there. But yeah, so Venezuela, again, I don't know where it kind of got cut off. But so again, more of a recent discovery, so bringing a lot of wealth to Venezuela, but also a lot of corruption since the politicians are kind of taking over and trying to figure out what to do with all that money. All right, continuing on. So these are in the U.S., the top 100 U.S. oil fields by reserve. So as far as oil in the U.S., where is the most of it? You can see a lot of it is in Texas. Go figure, right? Remember the old football team, the Houston Oilers? Well, because there's a lot of oil in Texas. But you also get a decent amount in the Gulf of Mexico as well. Some in California. In fact, that's kind of what drove people to Southern California, Los Angeles. Initially, there was actually a lot of oil there, historically, that they mined out. North Dakota, Alaska, more on this little blip up here in a minute. Before we go on, though, let me give you the first part of the super secret, or the second part of the super secret code. It is the number 3. You got me? The number 3. One more time. The number 3. So this is now looking at some of those bitumen deposits. So extra heavy oil and bitumen. So large deposits. Canada, more around the U.S. Oil shale. So that's more not much sand, but more kind of microscopic oil locked in rocks below ground. So we have some of those available here in the U.S. as well. Excuse me. So focusing in on bitumen and oil sands, looking at Canada up here. So this is a large section of where Canada's oil sands are, that they are kind of mining out. This dark green are native forests, natural forests, and you can see that this oil sands area versus what they're currently mining is right in the heart of that. So to do so, you're essentially ripping out some top layers of the ground. So you're essentially destroying the natural forest. So this is the yellow is the mineable area, black is where the active mining is. So it's a relatively small area, but what they could mine is this yellow, but where it's all located is the red. So you could expand to that, depending on what the Canadian government would allow. So liquid, petroleum, sand, oil sand, petroleum. So what are the advantages and disadvantages? So the reason we use oil, petroleum, gasoline is derived from oil in vehicles is that it's convenient to transport and use. It's relatively energy dense for what it is. So it's easy to transport and use. It burns really easily. It's energy dense, so it's great for things that move. It is cleaner burning than coal. It's not clean, but it's cleaner than coal. Oil, but is also used for many other applications, including plastic. Plastic, like this marker here, is made of plastic. Anything that's made of plastic, in order to make plastic, you need oil. That's a component of all plastic. All right, that's why plastics are nasty stuff. Disadvantages: release a lot of carbon dioxide into the atmosphere. There's possibility of leaks when extracted and transported. Oil spills, those happen very often. You can get runoff entering into marine, oceanic, different waterways. When you're burning oil, petroleum, gasoline, whatever, it releases sulfur, mercury, lead, and arsenic, just like coal. All right, just like coal. They're both fossil fuels. Some more disadvantage specific to one area is the Arctic National Wildlife Refuge, nicknamed ANWR, A-N-W-R. So this is an area up in Alaska, the northern parts of Alaska, the Arctic. So there's an area in northern Alaska where there are oil reserves. So what's the trade-off between extracting oil and the consequences of destroying habitats and possible species extinctions living near oil wells or pipelines? This is a very real reality in this location, the Arctic National Wildlife Refuge. Proponents of exploration, those wanting to explore in this area, suggest that the ANWR might yield 25 million gallons up to 378 billion gallons of oil. That's a big range. And substantial quantities of natural gas. So this could be useful for the future. So this is where Alaska is. This is where the Arctic National Wildlife Refuge exists in this whole area. And this is also where they want to kind of develop and mine out some oil. Some current oil fields exist, just to the west of this area, and there are pipelines that flow all the way from Alaska down to Valdez, Alaska. That's a seaport. I don't know if you remember the Exxon Valdez. That was a ship that crashed in the 80s, creating a large oil spill. Well, it was started here. That's why it's named the Exxon Valdez. So it's not where it occurred, but it's where it started. I forget where it crashed. But in any case, so again, it's should we mine out? Should we just take this National Wildlife Refuge, an area that cannot be used for anything other than wildlife and nature, and rip it up to get more oil? Is that in our best interests? Some people say yes, some people say no. So this is the Arctic National Wildlife Refuge. Gorgeous, grizzly bears, Kodiak bears. It's taking this and creating this or this. What do you want? When we mess with the environment, there's no good things that come from messing with the environment. The only positive of these things is, now we have more oil, so we can burn it more, so we can, whatever. Or we could just not do that and look for alternative sources of energy, hence electric cars. So, not all oil is mined on the ground. So when you drive by an area and you see these little things kind of going up and forth, they're pumping out oil. You can drive a number of places. I can recall driving to California and still seeing some of these out in the desert. But not all oil is mined from land. Sometimes it's mined from the ocean. Remember, these are deposits that are built up initially under the ocean, and sometimes due to plate tectonics, they're still there under the ocean. They haven't made their way to dry land. Plate tectonics hasn't moved things up or down, so sometimes they're still there. So we send out these platforms and drill down. We go down to the bottom of the ocean and we start drilling there. This is what oil sands look like. So we're getting all of this petroleum from different areas. So again, remember, this is the area up in Canada where once was forest is now whatever this is, taking up this dirty sand and trying to extract oil from it. So how do we do it? How do we extract bitumen? So you take the material, you kind of wash it essentially, you separate out the sand and water, you pipe it somewhere, you condense it, you filter out the oil. There's a number of processes and waste that goes into getting oil out of sand. Now, once you have that oil, whether it's directly out of the ground or whether you filtered it out of the sand, well, what do you do with it? How do we get gasoline from it, all right? Well, you heat it up. You take what's called crude oil. That's the stuff you would extract right from the ground, or what you would extract from the oil sands, and you heat it up. And then different hydrocarbons, different essentially molecules in oil get separated out to make the different things that we need. For instance, again, we heat it up, and then we pipe it in, and then if the stuff that cools down relatively quickly kind of gets trapped, it goes in different directions, right? So the lighter material, which burns at 300 degrees Fahrenheit, like gasoline, well, that kind of gets pulled off. Kerosene, a little bit thicker material, so it burns about 390 degrees Fahrenheit. Kerosene, some jet fuel. Diesel oil, a little bit heavier stuff. Motor oil, like a little bit thicker stuff, all right? That burns at a higher temperature. That's why we use motor oil in the engines. It lubricates, but it doesn't burn. You know what I'm saying? And then fuel for ships or candles, candle wax. So that's kind of hotter burning stuff, heavier, dense stuff. But then you also have some natural gases that are released that can be bottled as well. So you heat this stuff up, and as it kind of cools down, the heavy stuff goes to the bottom, the lighter stuff kind of goes to the top, and then we kind of extract it all out. This is what an oil refinery looks like. We're refining the crude oil into stuff we can use, and we kind of pull all this different stuff out of a barrel of oil. So, when we think about fossil fuels and oil, what do we want? Do we want this? Or, there are some people that say wind farms are uglier than this. I guess that's an opinion. I don't know. I think wind farms are kind of cool looking. I think oil's pretty. This looks gross. I don't know. It's kind of cool. Plastic. As the world switches to electric cars, do you think the oil industry is just going to go away? No. Right? Oil, you need oil to create plastics. So the World Economic Forum predicts plastic production is going to double in the next 20 years. About 12 million barrels of oil currently a year are used in making just plastic bags used in the U.S. That's just like your grocery bags alone, right? The average American throws about 10 bags, grocery bags away a week. That's 520 bags a year. The petroleum that went into that, it's equivalent of driving 60 miles. That's what you're throwing out. That's what you're throwing out. So 1 mile driven is the equivalent of 14 plastic bags. So every 14 plastic bags that you use and you throw out, that's 1 mile that you could have driven your car. Think about that next time you double bag. Or guess what? Why not just use reusable bags? Oil demand for the next 20 years, plastic is going to grow. Cars and trucks will kind of be less, but plastics are going to be the biggest demand, right? Oil companies still want to make money. They're going to funnel a lot of that oil into plastics. You just watch. You just watch. That's the prediction. All right. So we'll pause here. A lot to digest. When we come back, we'll talk about that third fossil fuel, natural gas. See you back here in just a second.